Hi guys, so we have an O-level past paper question from the year 2018. The session is May-June. This is question number 8. We'll solve questions on similar triangles and use ratios to find lengths and areas. So let's start. The question reads, OYC is a triangle. A is a point on OY and B is a point on CY. AB is parallel to OC. AC and OB intersect at X. Prove that triangle ABX is similar to triangle COX. Give a reason for each statement you make. So, if you look at this diagram closely, they mention that AB and OC are parallel to each other. Since they are parallel to each other, this angle right here and this angle right here would be exactly the same. Why? Because they are alternate angles. And this angle right here and this angle right here would also be the same because they are alternate angles as well. The third angle, this one, is also going to be the same as this angle right here. Why? Because they are vertically opposite angles. So the statements that we write are, the first one can be that angle ABX and angle COX are alternate angles. The second statement that we can make is that angle BOX and angle OCX are alternate angles. And the third statement that we can make is that angle OXC and angle BXA are vertically opposite angles. So there you go, we have the three statements and that proves that the two triangles are similar. Okay, let's move on. The next part of the question says OA is 3A and OC is 6C and CB is to BY is 1:2. Find as simply as possible in terms of A and C the vector AB. Okay, first label them. Let's label them. So OA they've mentioned is 3A and OC they mentioned is 6C. Then they've also mentioned that if this is one part, this is going to be two parts. What they asked us to find? They've asked us to find the vector AB. Okay. First of all, let's remove these signs over here first. One second. Not the 6C. That is going to be part of this question. So they've asked us to find this length over here. Okay, so we can compare these two lengths. If I compare this length with the length of the entire triangle, it would be in the ratio of 2:3. So that means if this is the length, this one is the length of the larger triangle, this is going to be 6C and this is going to be X. So we can compare them. So we can write if X is to 6C and 2C is to 3C, that means they simplify to so this becomes 2, so this would become this would be multiplied by 2 and X becomes 4C. So AB is 4C. I hope this made sense. We are just comparing lengths, so that's the reason why this becomes 4C. Okay, the next part of the question says find CY. So we have to go from this point to this point. Okay, let's have a look at the diagram that we have and let's see. Let's remove all of these scribblings that we've made over here. So one second, I'll just write the measurement so that it's easier for us to look at the question. So as mentioned in the question, this is 4C, this is two parts, this is one part. Now if this is one part, that means this is one part. So this part would be double of this part, that means this is 6A. So you go from C to O, then from O to Y. Oh, right. 6A, yeah. So if you go from C to O, you get 6C plus negative 6C because you're going in the opposite direction. And then when you go from O to Y, you get 3A plus the 6A. So the total becomes 9A. So this is your answer. Your final answer is 9A minus 6C. That is the vector. The next part of the question says, find in its simplest form the ratio OX is to XB. So they've asked us to find the ratio of this compared to this. The simplest way and the easiest way of doing this is if we compare the lengths of the two triangles. For example, the bigger triangle has the length as 6c. Since we're trying to compare the ratios, we don't need the actual lengths. And this triangle right here has 4c. That means 4 and 6 are being compared. So the ratio between them, of course, becomes 4:6, which is simplified to 2:3. So you write, sorry, OX is the larger one, so it becomes 3:2. Yeah, 3:2. Perfect. The next part says area of triangle COX and area of compared to area of triangle ABX. So COX is this triangle and ABX is this triangle. Since we have the ratios are 3:2. What we need to do is just square both of these ratios and we end up with 9:4. So this is the ratio between their areas. I hope this made sense as well. This is a very straightforward question. The last part of the question says area of triangle AYB compared to area of trapezium OABC. So let's clear this up and make room for the last part. They've asked us to find the area of this compared to the area of the trapezoid this. So in order to compare their areas, we have the length over here of AB, which is 4c. So we write 4c for a second over here. And then since we're trying to find the area of just this part so that we can compare it with the area of the smaller triangle, the area of the larger triangle would have been 6c squared, right? But the problem is that we remove this part so that we have a parallelogram, sorry, a trapezoid, a trapezium of OABC. So you subtract 4c squared from it and you square the other side as well. So what you eventually end up with is you're comparing 4c squared, or you can remove the square because we don't need the c, I mean you don't need the c over here, so you can remove the c. So we write 4 squared is to 6 squared minus 4 squared, because you're trying to remove the area of the smaller triangle over here so that you are left with the area of the trapezium. So 4 squared is 16 and 6 squared is 36 minus 16. You get 16:20, which simplifies to 4:5, which is your answer in this question. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.